Hello, welcome to the step-by-step tutorial on the development of 3D Slicer extension. My name is Sen Li. In this video, we will study the template module code given by 3D Slicer and distinguish the code area for developers and the code area for 3D Slicer so that we can focus on the developer area and learn how to program. Then we will clean the developer area for both graphics user interface and the Python script. Make the developer area need blanks to fill up so that we can make our custom module GUI Hello World. Let's continue from the last video where our Python project was still at t_apply threshold. We will read from the top to the bottom and figure out which area are for developers and which areas belong to Slicer that we don't need to consider about. The first class is our module class, which allows us to configure basic module information and acknowledgement. The template code connected a slot to the Slicer application signal startup completed to register sample data, but we may not want to use it. We can put a breakpoint here as a marker to remove later in the need blank section. The second class is the widget class. Nothing special in the constructor. We are now in the widget function setup, a very important function that deserves more commitment for a beginner. Step 0 belongs to the 3D Slicer. Step 1 and Step 2 is to load the graphics user interface. Step 3 is to instance the logic class. All the first three steps are well designed by 3D Slicer, and we don't need to pay much attention. Let's take a look at Step 4, the attachment of observers. We can navigate to the function onSceneStartClose to see what does it do. The two slot functions, onSceneStartClose and onSceneEndClose, are actually paired. Let's go a little downward. We can find that both two slot functions are called in setParameterNode. One is to reset the widget member parameter node to none, and the other one is to assign the module singleton parameter node to the widget member variable. The paired slot functions in Step 4 are important to the Slicer extension module, and we don't want to change it. So let's move on to Step 5. Step 5 contains the connections of signal slots, mainly for the communication between the graphics user interface and the backend data. This step is to be edited by the developers. We use the flag SLDeveloper to note the developer area as a focus. Step 6 is for module reload. We can keep it here and move on. The function cleanup remove observers. Function enter initialize parameter node, as we already learned from the tutorial section pipeline, and similarly for the function exit. We finished the two slot functions already, and here we are at the function initialize parameter node. This function is the second super important function for developers because it can be called for module setup, module enter, scene file reload, and Python script reload. And once the module singleton parameter node is assigned to the widget member variable, you will need to update the parameter node and attach observers. We put a flag here to mark the developer area. Now let's go to the function setParameterNode, where we can either reset the widget member parameter node to none or assign the module singleton parameter node to the member variable. When the module singleton parameter node is assigned, we first remove the observers from the old widget member variable, then assign module singleton to the member variable and attach observers back. After all observers ready for the new parameter node, we do an update of the graphics user interface based on the parameter node. This function is well designed by 3D Slicer, and we don't want to change it. The update of the graphics user interface belongs to developers. During the GUI update, we place a member billboard underscore updating GUI from parameter node to notify 3D slicer to prevent from infinite loop of updating. We turn on the billboard before we start updating as an open brace, and turn off the billboard when we finish the update. As usual, we put a flag here to mark this developer area. For the second update function, update parameter node from GUI, we check the member billboard in the beginning. Similarly to the GUI update billboard, we need to notify all property of the parameter node before we update the parameter node to disable any possible event signals, for example, the command modify event. After the update of the parameter node, we have to notify that the modification is finished. Both two update functions belong to the developer area. The function onApply button is a GUI response triggered by the push button apply. We will replace this function with our Hello World application. Let's put a breakpoint here as a marker to remove in the neat blank section. So far, so good. We finished the widget class, and the next class is the logic class. There's nothing in the constructor. The function set default parameter node is where we initialize the module singleton parameter node. It belongs to the developer area, but we may not use this function in the Hello World application. So let's put a breakpoint here to be cleaned in the neat blank section. The logic function process is a pure developer function for backend data process. It can be either replaced or removed. The purpose of this function in the template given by 3D Slicer is to show us how to make use of the test class for function unit test. Let's put a breakpoint here and then take a look at the test class. When we click the test button and run the test class will clear the murmur thing and run as many test functions as needed. In the given test function, we first register the sample data, instance a logic class, run the logic function process, and do the assert test. We will simplify this test function in our Hello World application, but for now, let's put a breakpoint here to be removed in the neat blank section. We finished the test class, almost there. The function of register sample data was put at the end because we won't use it in our application Hello World. So we can start the neat blank section by removing this function. Done. Now let's start cleaning the code and prepare the neat blanks from the top to the bottom. In the module class constructor, we remove the signal slot connection of register sample data. Moving downward, we remove the top GUI signal slot connections and comment out the statement for apply button to prepare for our application Hello World. We search the flag of SL developer to make highlight and moving downward. Here, the function initialize parameter node. In our application Hello World, we neither want to update parameter node nor attach observers. So we just keep a placeholder for the developer area and continue. Now it's the turn of the two update functions. There's only one push button Hello World in our application, so we remove the top update statements of the graphical user interface. We keep one set of the push button settings, change the object name of the push button to the push button Hello World, and replace the value of the tooltips and the enabled. Then we change the step index from 02 to 01. Perfect. Let's go to the second update function. We don't need to update the module singleton parameter node, so we clean this function and leave one statement commented out as a reference for the future. Here comes the slot of the push button. We change this function to our application response. Whenever the button is clicked, a queue message box is popped out to show us the GUI Hello World. Almost there. In the logic class, we skip the constructor and clean the function set default parameter, keep it as a placeholder for the developers. Then let's go to the custom function for the unit test. Our application Hello World is super simple, and this custom function is just to return a string that will be shown in the queue message box. Remember the slot function after we click the push button? When the push button is clicked, the logic custom function will return a string result to be shown in the queue message box. The message box title is Tutorial GUI Hello World, and the message is the result returned from the logic custom function. Now the logic class is done. Test class to go. We can directly go to the test function and customize it to assert our Hello World response. The custom function to be tested is the logic function obtain string Hello World, and we assert the string result is not null. Perfect. We only have one last step left, the file change of the graphical user interface. Now, let's go to the slicer and edit the GUI file. We click the button Edit UI. The template graphical user interface will be shown in the Qt Designer. We click one widget, select all, and delete. All we need is just one push button and one vertical spacer to push the button to the top. When we select the Q push button, we can find the object name of the Q push button in the property editor. Let's change the object name to Q push button Hello World, and then we change the text of the button to Say hello by clicking Q push button. Can we make this button more beautiful and change the background color when our mouse hovers over the button? Yes, we can do that. We right-click the Q push button and select Change Style Sheet. Here, I'm going to copy my style sheet, but you can find my code from the GitHub link in the description. We click OK. Our button changed. When our mouse hovers over the button, the background color changed. Perfect. Let's save the GUI file. But we forgot one thing. We did not connect the signal slot for our Q push button. Let's go back to the PyCharm and go to the widget function setup. This is where we want to connect the signal slot for our Q push button. I think we are done. We can now go back to Slicer and restart. We click the button Restart. Here we go. Let's go to our module and hover our mouse to the button. Click the button. And bravo! Let's make a summary. In this video, we studied the template module code given by 3D Slicer, figured out which code area belongs to the slicer area and which code area belongs to the developer area. Then we cleaned up the code in the developer area, generating a new Python template, which can be called neat blanks. In the end, we made a GUI Hello World application with a beautiful Q push button. That's it. If you have any questions or comments, please feel free to leave me a message and I will respond as fast as possible. I will see you in the next video. Thank you.